Neutron stars are city-sized balls of neutrons with incredibly strong gravity that warp space around them, creating intense gravitational fields and mysterious cosmic phenomena nearby always. These cosmic powerhouses form when massive stars collapse under their own gravity and explode in a spectacular supernova, releasing enormous energy into space suddenly. A sugar cube-sized neutron star would weigh about the same as Mount Everest on Earth somehow, creating an unbelievably dense and intense gravitational pull, warping space around it significantly always. Neutron stars rotate at insane speeds, sometimes hundreds of times per second, creating cosmic lighthouses that emit intense beams of radiation into space very rapidly always. Their magnetic fields are so incredibly strong they can cause nearby atoms to stretch into long, thin, mesmerizing shapes, creating unusual visual distortions in the surrounding space slowly. Some neutron stars emit intense beams of radiation regularly, making them pulsars that pulse with enormous amounts of energy through their magnetic poles naturally and visibly in space daily. These pulsars can be so precise they're used as cosmic clocks to measure time in space accurately. Neutron stars can have surface temperatures of over 1,000,000 degrees Celsius, hotter than the sun's core. If you were to get too close to a neutron star, your body would be stretched like putty by gravity. Some neutron stars are part of binary systems, orbiting other stars or even other neutron stars closely in complex gravitational dances, creating fascinating astronomical phenomena regularly. When neutron stars violently collide, they create massive gravitational waves that are somehow detectable from Earth, emitting powerful energy signals into space suddenly and unexpectedly, always. Neutron star collisions also create heavy elements like gold and uranium in the universe suddenly, releasing enormous energy that transforms surrounding space instantly forever. These cosmic crashes can briefly outshine an entire galaxy with a massive burst of brilliant energy and dazzling light, creating spectacular views in the vast universe suddenly. Neutron stars can have starquakes that release massive amounts of energy suddenly into space, creating powerful shockwaves that travel through their intense magnetic fields freely. Some neutron stars are surrounded by massive fossil disks of material left over from their formation billions of years ago, containing remnants of their turbulent past history slowly. Neutron stars can be recycled by accreting material from a nearby companion star, making them spin faster and faster in a spectacular cosmic dance, releasing immense energy. The fastest spinning neutron star known rotates 716 times per second, creating an extreme cosmic whirlwind with intense magnetic fields and enormous energy releases continuously. Neutron stars can be silent to us if their radiation beams don't sweep towards Earth somehow, remaining undetectable until they perhaps interact with nearby interstellar matter occasionally. Some neutron stars have mysterious glitches where their rotation suddenly speeds up for unknown astrophysical reasons, causing significant scientific interest and speculation worldwide daily. The core of a neutron star is so incredibly dense that its gravity is unmatched anywhere else in the vast universe, creating an intense, mind-bending environment. Neutron stars are cosmic laboratories for studying extreme physics under impossible conditions. Their intense gravity causes significant time dilation effects, making time pass noticeably slower near massive objects relative to Earth, creating interesting temporal comparisons and contrasts. Some neutron stars have atmospheres so thin they're almost a vacuum compared to Earth's. Neutron stars can be kicked out of their birthplaces by supernova explosions at high speeds, often traveling through space violently, creating spectacular cosmic displays and radiation. The study of neutron stars helps us understand the fundamental forces of nature better somehow, revealing complex phenomena and mysterious celestial behaviors in great detail always. Neutron stars are among the most efficient objects in the universe at converting energy into brilliant light, creating spectacular cosmic displays that captivate astronomers worldwide daily. Some neutron stars are guar, orphaned, and wander through deep space without being near any other visible stars, often emitting faint pulses that signal their lonely existence silently. The crust of a neutron star is incredibly strong, yet it can crack suddenly and cause massive starquakes, releasing enormous amounts of energy into space rapidly and violently, somehow daily. Neutron stars are crucial to deeply understanding the life cycles of massive stars in the universe, revealing complex astrophysical processes and mysterious cosmic phenomena regularly. So next time you gaze at the mysterious stars twinkling wildly in the night sky, remember, neutron stars are out there, pulsing with intense cosmic energy very wildly always.